Okay, the next discussion is we will discuss about the Hadoop distributed file system, what and how it's work, and what exactly what happened in the inside the process in the distributed file system in the Hadoop distributed file system. So before we know about it, you need to know about the Hadoop distributed file system have their own unique characteristic. Yeah, the main characteristic of Hadoop distributed file system is uh, the, uh, the Hadoop distributed file system, or HDFS, is store data redundantly on multiple nodes for persistency and availability. So that's the main function. So it's mean when we're using the Hadoop, our Hadoop distributed file system, actually we try to to store the data in the redundant way. Yeah, the redundant way is used for to ensure that we have the availability of the data that need to process in many nodes. And then, of course, after we have the availability, we will have the persistency. So the persistency, it means the processing of the data will be done in the appropriate time, and we can accept the performance. So this is the explanation about it. Yeah. So the Hadoop distributed file system, yeah, store the data on multiple nodes for persistency and availability. Yeah. So that's the key point, that if you have curiosity on the how the Google works, actually it can explain to you how the Google can be persistent and available. The availability is very high for the services. Yeah, yeah, because this is adopted from the Google file system. And the persistency and availability, actually the Hadoop distributed file system, we will have a very good performance, especially when deal with the huge file. Yeah, if we have only a very small file, Hadoop distributed file system actually is not as fast as normal, because it's like the Hadoop distributed file system is work for huge file. So if you have only one, for example, 1 GB data, actually it's not a good point for Hadoop distributed file system. And then the data will be updated in place. So in the Hadoop distributed file system, every update on the data that they has done for the processing event, it will be updated direct, and append are common. So this will be the typical usage of the Hadoop distributed file system. Yeah. So that's why the distributed file system, they have a very special item inside the Hadoop distributed file system that we call chunks. Yeah. So the data that's stored redundantly will be kept and will be placed in the chunk, that the chunk itself will be split across machine. So we will have a lot of chunk in every server and machine that they run the Hadoop distributed file system. So it is like the data packet or data chunk that will be available for accept and store the data from the distribution. And each chunk will be replicated on different machines. So they will redundantly, the data availability will be redundant in every server. So it means the availability will be high. There is close to the zero tolerance on the data missing or data loss, because data will be available across of the server. So when we, for example, if we have a lot of stuff in many places, it's mean we will very easy to use that stuff, and then we doesn't need to have the delay time to looking for and searching the stuff that we need to use, for example. So that's will be the function of the chunk. And then the chunk server also act as compute server. So it's very special in the Hadoop distributed file system. There is not only just used for storing the data, but also to compute. Yeah, in the chunk will be compute, and then bring computation to the data. So that will be the spatial things of the chunks. And yeah, for my opinion, we doesn't have the type of these chunks in the ordinary operating system. So that's why that would be the difference point of the operating system, the ordinary operating system that we until now we use. Even in the server, for example, I have the high performance computing server, for example, in the lab. If it's the server work alone, yeah, there is no chunk in there. Even I have the cluster, it's not have the chunk. It's only exists in the Hadoop distributed file system. Yeah, so that's very unique. Yeah. And what the typical of the chunk? The chunk server is the function is to split the file into contiguous chunks. Yeah, every chunk will be have a 16 until 64 megabyte data. So if we have a 1 gigabyte data, it will be cut in each of the chunk, maximum in this 64 megabyte. Yeah, and then each chunk is replicated, maybe usually twice or third, and then try to keep replicas in different blocks, so it will be placed into another block. So that's why this is the main reason why distributed file system is normally work into cluster computers. So that's why we have the master node that it will be in the name node in the Hadoop distributed file system. The master node will be stored the metadata about where files are stored in the chunk. For example, I try to store my data into server number 1, number 2, number 3, and so on, and also it will be stored in our master node as metadata, and then can be replicated. Yeah, it could be replicated. And then we have also the file access. Yeah, that will be deal with the master node to find the chunk server. Because the Hadoop distributed file system, there is a function that the server will be check first the availability of the server, and then if we have the availability of the server, yeah, we can store there. So it means the chunk is available for storing the data, and then connect directly to the chunk server to access the data. Yeah, that's within the main function of the MapReduce and the Hadoop distributed file system. And then in the Hadoop itself, that's the typical of the Hadoop common. Yeah, and then the distributed file system, we have a simplified distributed programming. Yeah? So when we add that, we call it MapReduce. So if you know about the MapReduce, it means MapReduce is distributed programming. Yes, this is the algorithm or programming component or function that in place in the Hadoop distributed file system that have two functions. The first is map and then the reduce. So the main algorithm is map and reduce. Yeah, so we call it the map reduce. Is it the only one simplified distributed programming? No, we have a lot of opportunity actually beside the map reduce. We have, for example, match aggregate pipeline procedure. So there will be the three steps of the map. In here is map reduce. Another thing is like match, aggregate, and pipeline. And we also have a different approach on the, for example, the architecture of the Elasticsearch is also different. So based on this case, you can imagine that in the big data processing is not only just running into the algorithm, for example, for machine learning, for classification, or maybe for clustering and etc. But to do the clustering and the classification, actually inside in the big data architecture, we deal with this simplified distributed programming to ensure that to run the machine learning algorithm in the simple way, persistent way, and availability is very high, for example. Yeah. So that's within the deal. So the MapReduce is the how it's work is very simple actually. For example, it's very simple way to explain is in the word count function. Yeah. For example, if we have a huge text and documents, so we need to count the number of the time each distinct word appears in the file, for example. So we need to count the distinct words. Yeah. So in that case, if we counting line by line, it will be very very long time and a lot of effort to do that one. So we can do into the MapReduce. In the real application, MapReduce is work for analyze web server log to find popular URL. So if you want to know, for example, in the network on the data center, we catch the traffic of the internet. We collect your destination address on your website in your browser, and then we can say that, for example, www.reddit.com is very famous and very common to access for today, for example. So we can use this MapReduce procedures. And then we can also the term statistic for search, which also work for MapReduce. So this is the concept of the MapReduce actually. So the MapReduce actually, for the previous explanation, is consists of map and reduce, but also in the intersection of the map and reduce, we have the group by key. Yeah, so this is very important. So in the map itself, we scan the input file record at a time. So we will try to scan all the content of the file in one way, in the one time, and then extract something we care about from each record. So we have a key. Yeah, so we have a key. For example, for the word count, if we have one file that maybe consists of 1,000 page in Bahasa Indonesia, for example, we will scan all the word that exists in that file and then extract something we care. For example, the word representation of that exists in that file, and then we have the key. So the word representation will be in the key. And then after that, we can do the sort and shuffle. And then the reduce will be do the aggregate, summarize, filter, transform, and then write the result. So that will be the main concept of the MapReduce. So in this case, actually, you can learn from the MapReduce if we build some algorithm that deal with the big data. So actually, we can we not only just directly process the data into the big data engine, but the most important thing is how we will process the data. In this, based on the MapReduce, we not only just counting, but we do the scan first, extract something that we will have the key, do the sort and shuffle, and then we have the result based on the aggregate, summarize, filter, and transform, for example. So that's within the. So that's why in this MapReduce, the MapReduce and group by key reflecting the workflow or the framework how the big data processing process works. Yeah. So that's within the Hadoop. So this is the illustration of the MapReduce work. So in this case, we will have the key. This is the key that will resulting from the scanning process. In every, so we will have a very unique and distinct key. And then we do the mapping. All the item of the data will have the key, and then in the time after all the data have the key, so we can summarize based on the key. So that will be the map. The process of the every single data or attribute have the key. It means we have the mapping process, and then we can counting or aggregate or reducing this because we can calculate based on the key, not based on the value or the attribute. So it's mean we just like do the what we call it a flag or assigning the data. So this is the how the MapReduce works, yeah. And also the key can be developed based on the group by key. So it's also will be make more easy to finishing the job of the MapReduce. And yeah, this is the input. This is the logical thinking of the MapReduce. Yeah, we have the input set of and then take the key value and output a set of key value. And then we have the map for every key and value that we have discovered before. And then after that, we can do the reduce. Yeah, all value with the same key and will be reduced together. So we doesn't need to to search each by each of the record of the file or attribute. So in one reduce function call per unique key, and we have the result. So that will be the MapReduce. And actually, the before I continue, the MapReduce will be help us to design the algorithm that if we want to develop by our own self, if we have a very specific data set and we need to run into the big data processing, so we can use the MapReduce as basic, and then we develop the logical thinking of the algorithm that we develop is on the MapReduce way. So that's actually that we want to discover and then to research. Yeah, not only just use the MapReduce, but we based on the MapReduce, we develop our own algorithm to very specific data processing. So that will be the challenge actually. And this is the real illustration for the MapReduce in the case of the word counting, and so we have a big document like this one. All the word will be scanned, and then the map will be read the input and produce a set of the key value pairs. Yeah. So if we have word the, we will give the number, crew, and so on, off, and so on. And if when we have a key and value, and then we'll be grouped by the key. So if the key have the same value, we'll be grouped by one as the same group. And based on this, we can reduce the duplication of this word. And for example, we have a crew, two crew, so it's mean we have a crew, we have space, we have we have suffer, recently, and so on. And in the reduce, we will have the distinct word that we looking for. Yeah? So in this case, and then we can do the statistical things to produce the number, to produce the pattern, and etc. So for example, if we want to develop the classification or clustering algorithm on top of the map and reduce, so we can do the same things. Yeah. So we can place the algorithm after we run the map reduce. So the map reduce will have the very distinct value, and then you can do the distinct value into your algorithm for clustering and classification. So that will be a good strategy for producing the result in a good way. Okay. And yeah, this is the pseudocode of the MapReduce. You can see in here, yeah, this is we have a map, yeah, consists of key and value. The key will be document name. The value is text of the document. For each word, W in value will be emitted by W and 1. And then the reduce have also the key and values. Yeah, so you can see in here the values will be a lot of number of values. So and then we will have the each count in the values. So the result will be have the key and result. So that will be the pseudocode. And another component of the Hadoop is yarn. This yarn is called yet another resource negotiator. Yeah, you can understand based on the long name. Yarn function is for resource negotiator or resource management. It means yarn have duty to allocate the job into the trackers, and then will be distributed to either node that can run the processing. Yeah, and then the MapReduce is improvement for this one is to have the scalability, and yeah, of course, to avoid the single point of failure actually. So this is the yarn, how it's worked. Yeah, inside the yarn, actually we have also two main functions. The first is global resource manager. The global resource will be the main function as resource management. It means the global resource manager have all the information of every node that involved in the Hadoop distributed file system. Yeah, so all the node will be registered in the global resource manager, and all the all the results will be monitored by the global resource manager. And then in the global resource manager, we also have the application master. A specific job of the function of the application master is to do the job scheduling and monitoring. So the application master will be allocate the job into the idle capacity of the node, and then monitor which is the job is done or not. And then if they have problem, they will route to another node that ready to process the data. So it will be like the station managers to reroute if the data doesn't meet the available node that can be worked on from them. And based on this image, you can see if we have a client is mean the task, yeah. So it will be registered on the job tracker. So it can be like we will give the ID to every job that going on to the Hadoop distributed file system, and then job tracker will be allocated to the node. So every node will have a task tracker, and then the task tracker will do the task. And if the tasks run in the computation node, the process and then the result will be reported to the task tracker and communicate to the job tracker. And another node will be have a same process. So in this case, the job tracker that in the application master and global resource manager, you will have a very huge and very busy process to handle the job tracker and then job submission that going on in the Hadoop distributed file system. So based on this scenario, so we can understand that to run the Hadoop yarn and then the Hadoop ecosystem, so we really need not only just a very simple server, for example, for like single server, ordinary server, but we need to at least high performance computers. And then if very ideal, if we have like a cluster based computer, then can we work parallel in the maybe 2, 4, or 8 node, and then work together in the single global resource manager. Yeah. And this is the task tracker. The task tracker will be placed in the node manager. The duty is launching the application container, monitoring resource use, and reporting to resource manager. So this will be the node manager. And yeah, you can see in here, this is how the reporting and status delivery to the server and to the resource manager. So it's very easy. Yeah, resource manager will be track all the tasks that is done, because sometimes we can avoid that the tasks will be failed not only in the node but also in the transmission. So because of network latency, or maybe we have problem in the network topology and so on. So it's mean we have problem on it. Yeah? So that, for example, if we have very long range network, so we have problem on it. Yeah. And then in the yarn, try to deal with the fault tolerance and availability, because the global resource manager task is to have the ensure the no single point of failure. Yeah. So you will know about Zookeeper. Zookeeper is one of the technologies that also work in the yarn to monitor all the nodes in the hardware resource is working properly. There is no problem on it. So if we have problem on it, it means the work that we allocate to node we also have a problem. Yeah. And then they do the application master they started automatically on RMC start. If we have any problem, all the node will be worked automatically to restart or to solve their own problem. So it doesn't need a lot of intervention from the human. If as a big data administrator, for example, you already run the good or appropriate configuration. And then the application master, this is optional failover via application specific checkpoint. And then And the MapReduce application pick up where they left off via save state in HDFS. So this is the yarn is support like for Spark and Storm. This is the batch and stream processing that I has discussed previously, the early of this presentation. Yeah. So this is the explanation of the Hadoop command. So hopefully you now understand why Hadoop distributed file system actually is very very challenging to discuss, and then a lot of discussion inside the technology. So actually, this is very good point. If you have your, for example, for your final years thesis and similar for your project, for example, you deal with this because a lot of point that we can raise as your subject on your thesis, for example. For example, about the analysis on the global resource managers or application master, what the performance on it, the negotiation between resource manager and node manager is also very challenging to discover about the pattern. Not only just use the MapReduce for doing the classification and clustering algorithm, but also we think about how it's work, and we try to analyze and identify in what point we can increase or enhance the capability of this engine. Yeah. So hopefully this after this you really understand about it. Yeah. If you have any question, please you can state now.